Alright guys, here's a super quick video here on calculating gram formula mass. If you did not already watch part 2 of the video notes, please make sure you do that before you try this, because the information covered in that video is needed in order to do gram formula mass. And the only people that need to be viewing this video are honors students. If you're in an academic class, this is not something that's being taught in class. It's not something that I'm expecting you to know or I'm going to test you on. So for gram formula mass, this is really about calculating the mass of a molecule or a set of molecules. So we need to identify how many elements we have. We need to identify how many atoms of each element we have utilizing subscripts and coefficients. And then, which we've all done that's all part of this part 2 video. But at that point, we need to, instead of adding up how many atoms we have, we need to first turn our attention to the periodic table. And we need to look up the mass for each element. And then once we've done that, we need to multiply the mass of each element by the number of atoms of that element that we have. And you do that for each element, and then add that all up together. And that tells you what the mass of a formula would be. So for instance, if I'm going to look at the element, or the compound H2O. I got H2O, and I apologize for the handwriting. It's done with a mouse, so it's not going to come up super neat. So I have this compound. I have H for hydrogen. I have that as one element, and I also have O for oxygen. That's another element. And I want to count up how many atoms I have. Well, I have, on each molecule, I have 2 hydrogen and just 1 oxygen. Now, I don't have any coefficient here, so I don't have to worry about multiplying by the number of molecules that I have. I only have 1 molecule. So my next step here would be then, instead of adding up, go, oh, I have 3 atoms. I need to actually look to the periodic table and find my mass. So I look to the periodic table and I find the mass of hydrogen. And the average mass of hydrogen, rounded to the nearest whole number, is 1 AMU. 1 AMU. And then I look at my oxygen, and I find that on the periodic table, and I find that has an average mass of, when rounded to the nearest whole number, 16 AMU. So again, we're always rounding to the nearest whole number here with our units, or rather with our average mass. So now that I have that, I have 2 atoms with each one a mass of 1 AMU, means that I have 2 AMU worth of hydrogen, and then I have 1 atom at 16 AMUs apiece for oxygen, so that is 16 AMUs in total worth of oxygen. And then I add these up together, and 2 plus 16 gives me a mass of 18 AMU in total. So the total mass of this compound is 18 AMU. That's all gram formula mass is figuring out what the total mass of a compound or a molecule or a set of molecules is. So if we try this with another one that's a little more difficult, like H2SO4, sulfuric acid. H2SO4 is my substance. So I have H for hydrogen, I have S for sulfur, I have O for oxygen, and then I go right to the periodic, or I count up my number of atoms using my subscripts and coefficients first. No coefficient, so I don't need to worry about that. But I have 2 hydrogens, I have 1 sulfur, and I have 4 atoms of oxygen. I need to find my mass off my periodic table for each one of these. So hydrogen has an average mass of 1 AMU, sulfur has an average mass of 32 AMU, and oxygen has a mass of 16 AMU. Again, I just found that from the periodic table, and I round to the nearest whole number, and then I multiply. 2 atoms at 1 AMU apiece gives me 2 AMU. 1 atom at 32 AMU apiece gives me 32 AMUs worth of sulfur, and 4 atoms at 16 AMU apiece gives me 64 AMU worth of oxygen. Then I add this all up, and when I add this all up, I get 98 AMU. So 1 molecule of sulfuric acid, or H2SO4, has a mass of 98 AMU. Again, you should make sure you're writing your unit here. You should never skip that out. If you're skipping writing your units, you're going to lose some points. just for sake of time, so you don't need to see me write this all out, I didn't write it here, but you should always write that in all these places here so you remember what your unit is as you work through it. So that's just kind of the simplicity of gram formula mass. Now looking at kind of one additional option, well, what if I had 2 NaCl? We didn't look at one that had a coefficient, but the same thing still applies. Per compound or per molecule, I have 1 atom of sodium and 1 atom of chlorine, because there's a little magical invisible 1, a little magical invisible 1 here. And then I have 2 of that compound. I know that because of my coefficient. So my total number of atoms of sodium is 1 per compound times my 2 compounds gives me 2. I have 1 atom of chlorine per compound, but then I have 2 of that compound, so 1 times 2 is 2 total atoms of chlorine. Then I multiply by my mass. So if you do have a coefficient, you kind of just have to insert that step in the middle of multiplying by your coefficient before you multiply by your mass. Then you find your mass in the periodic table, multiply, add everything up, bang, there you go. So 2 molecules or 2 of the compound NaCl gives me a total mass of 118 AMU. So there are some for you to try on your page. And so if you want to pause the video for just a moment, you can come back and I will provide the numbers, the answers for them. So you can go ahead and do that now. Alright, so if you've added these up, for NaCl, there should have been just a single NaCl. To practice on your notes would have had a mass of 58 AMU. For NaCl, it would be 30 AMU for C2H6. For CuNO32, you'd have a mass of 188 AMU. For CaCl2, you would have had a mass of 110 AMU. C6H12O6 would have a mass of 180 AMU. And 2AgNO3 would have a mass of 340 AMU. So if you have questions or if you're having difficulty, shoot me an email or stop in and see me to get a little clarification. But this is the basics of how we calculate the mass of a formula called gram formula mass. Thanks, guys. Have a good one.